Welcome to Summarize Science. We know AI can be incredibly powerful, but it can also make strange, nonsensical mistakes. In science, these mistakes aren't just funny, they can be disastrous. Imagine a simulation that creates energy out of thin air or violates the basic law of conservation of mass. Researchers call this phenomenon hallucination, where the AI model produces a result that's mathematically plausible but physically impossible. It happens because the AI is focused on matching the data, not obeying the fundamental rules of the universe. This paper, Learning Under Laws, introduces a groundbreaking framework to solve this. It's called Constraint-Projected Learning, or CPL. Think of normal AI training like a car rolling down a hill to find the lowest point. The problem is, that car can easily roll off the road into a physically impossible ditch. CPL essentially builds guardrails along the road of physical reality. At every single step of the learning process, if the AI's prediction starts to violate a law, it's instantly projected or pulled back to the nearest physically correct state. The AI is forced to learn inside the laws of physics, not just beside them. These aren't just one or two rules. The system enforces everything from conservation of mass to the correct behavior of shockwaves. The researchers also added a technique called total variation damping, or TVD. This acts like a smoothing filter, preventing the AI from creating tiny, unrealistic wiggles or oscillations in the results, which is a common problem. Finally, they use a rollout curriculum. This means they train the AI to make accurate predictions not just one step into the future, but many steps, ensuring it remains stable and reliable over long-horizon simulations. So, what's the result of all this? The method produces solutions that are not only accurate but also strictly obey the physical laws they're modeling. This graph shows how a standard model can drift over time, while the CPL-trained model stays stable and accurate, even over many prediction steps. Mass and energy balances are preserved down to machine precision, meaning virtually no errors. And the growth of those unrealistic wiggles drops to zero. So let's recap the key breakthroughs. The core idea is constraint-projected learning, which forces the neural network to stay within the boundaries of physical laws at all times. This eliminates hard hallucinations, like creating mass from nothing. Adding total variation damping suppresses soft hallucinations, like non-physical oscillations, making the solutions smooth and realistic. The rollout curriculum teaches the model to maintain this lawful behavior over long periods. What does this mean for the future? It means we can build AI-powered scientific simulators that we can actually trust. This could revolutionize fields that rely on complex simulations, like climate science, aerospace engineering, and materials discovery. Instead of just hoping an AI learns physics, this method makes it a built-in property of the learning process itself. It's a huge step towards creating AI that doesn't just approximate reality, but truly understands and respects its fundamental rules.